Welcome to homework.
Okay, we have got some sort of equilibrium. We're not quite sure. That's what we're trying to determine. And I'm going to go ahead and copy this now. Okay. Oops. Okay. And the idea is that on this side, we have hydrogen here. And on this side, we have a lone pair and a negative charge. Okay. And on this side, we have Cl minus. And on this side, we have HCl. Okay. So effectively, what's the transformation has been is that this chlorine came and deprotonated that proton, right? And we want to know, what's the equilibrium situation? Is it, kind of equal? Is it favoring one side over the other? Favoring the left-hand side over the other? Um, well, this is like a resonance arrow, so it's not that, but yeah, is it equal or is one side favored over the other? And then just don't use the resonance arrow because it's just the wrong type of arrow. So the real options are then, let me get a nice thicker pen. Okay. Equal favors the right. What am I doing? Or favors the left. Okay. How do we determine this? Well, we just compare the pKa's, right? Recall that if we have some equilibrium K for that equilibrium going from left to right for an acid-base reaction is going to be equal to 10 to the pKa H of our conjugate base minus the pKa of our acid, right? So that's like saying it's going to be the pKa is for HCl is less than 10 and or less than 0, and for I think alpha, I forget. This hydrogen is alpha to 2 carbonyls. I still think this is around like 8, the pKa. Okay, right. So we can do this with math, right? We can say this is like 10 to the less than 0. Let's just say 0 minus 8 equals 10 to the minus 8. Okay, that's really small. That heavily favors the left. Okay, that's one way of doing it. The other way of doing it is saying, okay, without math, is saying, okay, what's a stronger acid? This carbon with the hydrogen or HCl? What's the stronger acid? Okay, I know this proton is fairly acidic, given that the carbon is alpha to 2 carbonyls. But we still know that carbon-hydrogen bonds are far stronger than hydrogen-chlorine bonds, right? Like, you'd have to really, really engineer some very interesting molecule to get a carbon-hydrogen bond to be more acidic than an HCl bond. I mean, this is a canonical strong acid, pKa less than 0, right? So we should know intuitively that HCl is the stronger acid than this carbon-hydrogen bond over here. For that reason, we should expect that the stronger acid, the side where the stronger acid is together, should not be favored, right? It makes far more sense for this carbon to have hydrogen than for chlorine to have hydrogen, right? The question is like, is this going to grab a hydrogen or is this going to grab a hydrogen? If they were fighting over a hydrogen, like, oh, I want the hydrogen. No, I want the hydrogen. Who's going to win? The carbon. The carbon is going to win, which means that the equilibrium lies to the side where the carbon won. The carbon won on that side, right? So the equilibrium is going to be, strongly favoring the left-hand side.